Williamson, and I wanted to put together a short demonstration video on how to use Netlogo, and specifically a Netlogo application called Enzyme Kinetics. It's a model. What we call an agent-based model. Agent-based means that we have these small little agents that have properties and behaviors individually, and we put a whole bunch of them in a place and let them interact according to rules and see what happens. And with that, we can modify. I mean, that's very similar to what enzymes are, aren't they? They're agents that interact with substrate and produce product. Each of those things are, um, we could look at them as if they were individual agents with different properties. And that's what we have here. This is a web-based Netlogo, runs in a browser, so that makes it real easy. It's a little slower than the Java-based that you can pull in and work with. But the nice thing about this is it'll work on all your browsers. So I have it working in Chrome right now. So there's a lot of stuff here that we're not going to cover. What we're going to really try to do is create a Michaelis-Menten curve with the data that we're going to be creating. But one thing you might want to look at is anytime you bring up a Netlogo model is to look at the model info. And right here is, if you've been following along on the yeast catalase series of posts that I put together, this should look familiar. Enzyme plus substrate. They interact at a rate, which we have as a constant here, forward constant, and they dissociate and to make a enzyme substrate complex, and they dissociate back this way also at a certain rate. Obviously, you want this way to go more than this way in order for this reaction to go forward, or do you? That's a question you can actually explore with this model. And then there's this Kr, which is your reaction rate as where this enzyme substrate complex breaks the substrate into product. And this particular model models a very similar enzyme as the catalase. It takes a substrate and breaks it down into product. So this is kind of cool. Let me shut that down. And and we're just going to play with these constants. So unlike the Michaelis-Menten, where the model, the symbolic model is converted into a mathematical expression with slightly different terms than just these constants, now we're just going to play with the constants because we have these individual agents that we're going to try to model. So if I set this up, put 50 substrate molecules in my world right here, and I've got mucho plenty of these enzymes. Let's see what happens. So I hit go, and you can see I'm getting substrate enzyme complexes, enzyme substrate complexes. That's represented by this red line. And we're getting them to dissociate and go back, but I'm not getting any product. I'm not getting any blue stuff. Why not? Let's stop this, reset this up. Well, the reason is that our constant for our reaction is 0, so it never breaks it down. So what happens if I change this to 50? I can move this slider over. It's kind of hard to hit 50 sometimes, so I'm just going to do it like this. And if I now tell it to go, let's see what happens. Try that again. Now we have product. And you can see it was pretty rapid as well. Okay, let me stop this till it's set right up again. Let's watch that again. Go. Okay, they're almost exactly the same form right here, but there's no Michaelis-Menten going on. What's up with that? Well, we have to actually try different concentrations of substrate. So that's what we're going to do. We'll go ahead and leave our constants at these particular values, but this is one thing you'll want to explore when you explore a model. So let me set this up. New, everything's new. And let's hit pause. And what that'll do is after 30 time intervals, 30 ticks, it'll stop because that'll kind of catch it at the early part of this rise right here, or the other way around here if you want to look at it that way. So let's take a look. Okay, I'm going to tell it to go, and it's going to stop, and it gave me a velocity, an initial velocity of 1.345. Now, what I can do is I can record that by hitting record, and now I have a data point. Very nice. What's also nice is I can tell it to set up again, say go again, and I'll now have a new data point at that same substrate concentration, and you notice it's different this time. Just slightly different. Why is it different? Because every one of these agents act on their own, and there's certain random part of this, and so it's going to be different each and every time, much like a real world environment. So this is a really neat modeling system. I'm not going to take multiple samples right now at these different concentrations, but I am going to go through and create this curve, and I'm going to speed things up a bit. So I'm going to now double our enzyme concentration, and I'm going to tell it set up, and I'm going to tell it to go. Didn't take very long, 2.621 record. Going to double it again, the substrate concentration that is. Whoops. I'm going to tell it set up, tell it to go. Now it's 5.172. Why is it going up? That's something to think about. Yes, record it. Now I get this kind of almost linear, but I think you know what's going to happen. If I keep on doubling, 400, go. Ah, yes, indeed, it keeps going up. So I'm now up to 8.4. Let's go to 800. Let's do a setup. Tell it to go. Let's take a little bit longer. It's up to 10. Record. And you notice now it's starting to level off. Let's do one more doubling. Let's go to 1600. Till it's set up. This is going to be really packed in here with, yeah, there we go. With substrate. Let's tell it to go. And we have created ourselves a nice little Michaelis-Menten plot. And you notice it really has leveled off now. Interestingly, one of the things your students might want to do is go in here to the code itself and modify it in a way that it keeps track of the data, so you don't have to now, because right now, if you want to actually keep track of those numbers, you have to write them down. That's not bad. In fact, I'm going to show you a table that I did with 8 samples at each one of these concentrations so you can see what it is. But likewise, you can go in here and change these and do another Michaelis-Menten plot and really explore how all these different constants and changing them affect enzyme action, which should really help you develop some content ideas with the students that are based on some really deep understanding, or deeper understanding than typically might find in a classroom. Anyway, I'll let that go at that, and I hope this is helpful. I hope it serves kind of like a catalyst. Yeah, that was intentional, to get you and your students up to giving Netlogo a try, because it can be a very powerful tool in the classroom. All right, later on.